Hello, I'm Dr. Joel Gooden. I'll be teaching statistics and research methods. I hope that you're excited to be in this course. Pay attention, keep up, use the study guide, use the textbook, and use these video lectures. You will do fine. Create some tasks for each week for yourself. Here are some examples. Read Chapter 1, review Appendix A. We'll be taking a look at that. Take a look at your syllabus. That's our contract of how we're going to do things, what I expect from you, what you should expect from me, how you'll be graded. Contact information. We're going to have a quiz each week. You can practice for that quiz by looking at the study guide, and since it is adapted directly from the quiz, it should cover the same content. Make some practice questions or find some practice questions and practice them until you get them perfect. Then you'll do better on the quiz. Alright. Statistics are not just for grandpa. All you need for this course is what you learned in high school. You may have forgotten some, but you'll quickly recall it. Statistics refers to a set of procedures and rules for reducing large masses of data to manageable portions and for allowing us to draw conclusions from those data. One important feature of this new phase of statistics is that we focus on whether the data in our findings and the findings from our data are meaningful. It doesn't do any good to be able to ask if two groups have different averages if the difference in averages has nothing to say about the real questions we're asking. It does no good to say that a difference is not due to chance without also giving some idea of how large the difference is and whether it makes an important difference. Statistics allows us a way of making more informed decisions. If a news article tells you something, do you trust it? While watching an election on television, do you wonder how they know that it is acceptable to say that a certain candidate won the election even though all the votes have not been tallied? Traditionally, statistics have been concerned with whether the difference found in experimental groups was reliable. The focus now is on whether the difference is also meaningful. Therefore, current statisticians focus more on effect sizes, confidence limits, or confidence intervals, which give us information about how confident we should be when making judgments about an entire population, based on data collected from just a sample of the population. Most of you should have read in the book already about the experiment with morphine tolerance. The idea is that taking morphine over a period of time reduces the effect that morphine has on our bodies. Think about living in Florida. I did. When I first moved there in 2004 from Arkansas, the days seemed very, very hot. However, after living there for 10 years, I became more acclimated to the heat, such that what was hot before did not feel quite as hot. This is the way many drugs work on our bodies, both the legal and illegal ones. If you've recently started an exercise regimen, you realize that the workouts seem easier and easier as time passes. This is another type of tolerance. However, the importance of the example in the book is that we may build up tolerance to a drug like morphine, but that tolerance may not apply if we tried the drug in a novel or new and unique situation. That's how ODs occur. This is one way they occur. Context matters. When I look at studies, I often ask or read where it happened. Did this study occur with lab mice in the laboratory with white walls, a maze, and no outside air or distraction? Or did it occur with real people in a real environment in a real statistics class? I need to know where the data was collected and how the experiment was done so that I will know a little more about whether the study is applicable in real-world situations. If it happened in a laboratory, it may not be rational to generalize it to the real world. Think about studying for a test in your quiet room with no distractions. Think about how different it is to come into the classroom filled with tense students just like yourself and the emotional pressure of that situation. The time limit, the professor brooding over you, the girl next to you smacking her gum, the guy in front of you with body odor. Again, context matters. A lot of you have experienced descriptive statistics. These give you information about something, such as how tall is someone on average in North Korea. It's important to information about their characteristics. It simply describes a set of data. It is not trying to prove anything, predict something, or generalize to a wider population. Sometimes we do want to use data from a sample to better understand the population. Many of us are guilty of using one event in our lives to say something always occurs. If I ask my sister if she likes pizza, and she says very much so, can I then say that all females like pizza very much so? Of course not. My sister does not represent all females. But what if I ask someone more important, like Hillary Clinton, Condoleezza Rice, or Oprah? What if I asked all three? Could I then say that whatever their view is represents most, if not all, women? No. We get in trouble when we try to make broad conclusions from very little data. Have you met anybody from Vietnam? What was your experience? Are you guilty of thinking that most Vietnamese people are like that person? Of course, you could have had a good experience, and that would generalize to all Vietnamese people. However, you might have had a bad experience that could lead to stereotyping, racism, and discrimination. In our lives, as with research and statistics, we must gather sufficient data or information before making conclusions. We're not interested in studying things that don't vary. In other words, things that are static or don't change are not interesting. It would be stupid to do a study on how many ears my sister, Oprah, or all females have. Typically, the number of ears a human has does not change. Studying it does us very little, if any, good. But what if I studied the amount of information that different people take in with their ears? I can have people listen to a phone conversation and write down their understanding of the content and the emotions of the person sharing the content. This would be different for each individual. In other words, the findings, the results, the data would vary. In situations like this, where many people would need to be studied and a lot of data would need to be collected on several observations, I would need multiple measurements. We want to be able to use statistics to infer values of our population. Our statistics measure a sample of the people that we actually talk to, not just my sister or Oprah, but a good representative large group of women. A large group would be more around 700,000 or as small as 1,500. What about all women in existence? That would be called the population. Unfortunately, it's almost always impossible to get information from an entire population. Therefore, we choose a sample that we believe can be representative of the entire population. If we're looking at women of all ethnicities, we wouldn't just want my sister or just Oprah. We would want women of all colors, ethnicities, and cultural backgrounds. In whatever way we limit our sample, our ability to generalize to a population is also limited. It's important to think about how we get a sample. Who is most likely to fill out my survey? The people that are most interested in it. The people with free time. The people that want to look good. Are those people representative of everyone? Maybe. Probably not. If possible, I want to randomly select people from my population, such that my sample is not affected by bias. Think about if I was studying altruism. It would be very important not to just take the first 100 people to volunteer to take my survey. Those people would be naturally more altruistic or socially helpful than the general population. That would mess up or confound my study. This is why we want to identify people in a population, create a random number list, and identify potential participants without bias. Can a study be without bias? Probably not. However, we can take measures to minimize bias. It's actually rare that I can use random sampling because it is so difficult. More often we use a convenience sample, or a sample of people that are willing to take our survey or do our experiment. As researchers, we must think about how inherent biases in the selection process may affect our results. By thinking about it, we may find a way to control for a possibly confounding variable. It all comes back to whether we can make a logical inference that we can trust. I have a friend who's contracted by the DoD, the Department of Defense. He uses statistics to prevent events that may happen. I honestly don't know how he does it, but it's very advanced statistics. When he suggests that something might occur, like a terrorist event, he needs to be very sure that his prediction is logical, that his data selection is not biased, and that he accounts for any confounds. I'll see you next time on Emphases.